Okay, so we're back differentiating trig functions. Now, before I even start looking at the examples from the slides, you really need to be aware of what's on that reference sheet and use it, okay? So always go back and check. Just have it in front of you because it's easy to make a mistake if you're in a hurry trying to answer the exam question and you know it's there, so you can always double check. So we know that the derivative of sine x is cos x. The derivative of cos x is negative sine f of x. And the derivative of tan is sec squared f of x. All right. And of course, this at the front is telling you to differentiate. If that was 2x, then the derivative of 2x is 2. So I will end up with 2 cos 2x. If there was a 3 in front of cos x, well, the derivative of 3x is 3. So that's negative 3 sine 3x, and so on. So there's the idea, and then we can develop on that later. All right, let's have a look at the first example from the slides. The first example says to differentiate and find the gradient when x equals pi on 4. So let's start. So here we have y equals sine x plus cos x. So dy dx is equal to, all right, what's the derivative of sine x? All right, well, the derivative of sine x is cos x, and the derivative of cos x is negative sine x. So there's my derivative. Okay, now when x equals pi on 4, that gives me the gradient of the tangent at that particular point. We know the derivative is cos x, so substitute cos pi on 4 minus sine pi on 4. Okay, so the gradient of the tangent, because it's what the question is asking us to find, we end up with, well, cos pi on 4, that's 1 over root 2. Sine pi on 4, that's sine 45, is 1 over root 2. So we end up with 0. Okay, all right, that's the first one. Then there's a part B to this question. Okay, let's differentiate. dy dx, the derivative of x is 1. The derivative of tan x is sec squared x in this case. Right, but there's a minus, so it's minus sec squared x. I don't need the bracket, you can just leave it without the bracket if you prefer, doesn't matter. Okay, now when x equals pi on 4, right, the gradient of the tangent is going to be 1 minus sec squared pi on 4. All right, now if you remember, sec is, what is that equal to? 1 over, sec theta is 1 over cos theta, sorry. Remember the third letter tells you, so that's how we know. Okay, so we can change that to 1 minus 1 over cos squared pi on 4. Okay, that's the same as that. Or I can just, yeah, let's leave it like this. Okay, so then what happens here? Well, remember cos pi on 4 is 1 over root 2, and then so that becomes 1 minus 1 over root 2 all squared, and of course I can bring that to the top. So really that becomes 1 minus 2, so the answer is negative 1. Okay, so there's that answer. Okay, now that's the first example. I need to write this off so I can do the next one. Okay, but I'm going to leave those derivatives there so we can keep referring to them. So, example 2. Okay, for example 2, the question is, yep, if we have, oh, that's right, f of x is equal to sine x. There goes the lid. Okay, I need to find the derivative of that function and then substitute 0. That's what I'm asked to find. Okay, actually this is a really good question because we are, thought it had stopped, sorry guys. This is a really good question because we're going back to what we did at the start of this topic, where we're actually finding the equation of the tangent at 0, 0. That's what we're asked to find eventually. All right, so let's go. Let's first of all find the derivative of sine x. So f, this is part of the question, f of dash x is equal to cos x. All right, when I substitute 0, I end up with cos 0, which is equal to 1. Okay, there's 1. Okay, and then, so this is the derivative, so this is the gradient of the tangent. And then I'm asked to find the equation of the tangent at the origin. Equation of tangent at the origin. Okay, here we need to use the point gradient formula, right? So we know what the gradient is, we know the point, so that's y minus 0 is equal to the gradient, bracket x minus 0. Okay, that's just y equals x. And now this, you should be remembering what we looked at in the last, as I said, when we started this topic. This is an important result because we're actually looking, if I was to graph this, it actually asks you to graph, the question is asking you to graph it. Graph the function y equals sine x. So y equals sine x, I'm going to go up from here, and okay, so there's 1, 0. Okay, so what's happening here? Let's have a look. I have the tangent equals y equals x. So this, you need a different color. Let's go with red. This is y equals x. Okay, so when x equals 1, y equals 1. When x equals -1, y equals -1, and so on. So this is showing that very important rule that we looked at before, the limit of x approaching 0 of sine x over x equals 1. Okay, now remember, a limit is the value that this function, right, is approaching as x is approaching 0. So as x is approaching 0, and we have the sine function over y equals x, we get the derivative, okay, which is the tangent, which is equal to 1. Remember, this defines the derivative. So that was an important result to have a look at, an interesting question, because it just, hopefully, it makes this a little bit clearer as well, what we're actually doing here. When we differentiated sine and we substituted x equals 0, we get the gradient of a tangent at that point. And at that point, remember, at the origin, 0, 0, we get the line y is equal to x. All right, and that's our result there. Okay, that was example number 2. Now, let's have a look at example 3. This off. So example 3. Okay, is asking to find the derivative. So 3a, y equals cos bracket 3x plus 4. Now, it's asking to use the chain rule to do it. So I'm going to show you both ways, with the chain rule and without the chain rule. Okay, so you remember the chain rule is dy dx is equal to dy du times du dx. Okay, chain rule. Oops. Okay. So where do we start? We say let u always be what's inside the brackets. So let u equal to 3x plus 4. So du dx, I differentiate for x, I end up with 3. Now, y, so this original function becomes cos u. And now I differentiate and find dy du. Now the derivative of cos, if we go over here, it's negative sine u. Okay, so going back to my chain rule and I substitute all that in, what do I end up with? Well, dy dx is equal to my dy du, which is down here, negative sine u, times my du dx, which is 3. Same as saying negative 3 sine u, but u is 3x plus 4. So the answer is negative 3 sine bracket 3x plus 4. Okay, now remember, math is all about patterns and things that are happening. So this is one method of finding the derivative of this function. But if I didn't want to use the chain rule, I can also use, I can just figure it out. Look, dy dx is equal to, right, using this rule here, the derivative of cos is the derivative of what's inside the bracket, the f of x. So this is my f of x here. So the derivative of that is 3, all right? So that's my f of the derivative, f of dash x. So that's 3. And then the derivative of cos, we know it's negative sine. So that's why there's a negative up the front here. And my f of x is 3x plus 4. And see, I end up with the same result, and it's a lot quicker. It's just using the rules that are already on that reference sheet to make your life easier. Okay, so that's the answer for 3A. Okay, I think you can do B and C, or I might just quickly do B using this method instead of the chain rule. So for B, the question says differentiate y equals tan bracket 5x minus 1. Okay, same idea applies. Dy dx is equal to, back to your reference sheet, right? This is my f of x here. So I need to find the derivative of that, which is 5. Okay, now the derivative of tan x is sec squared x, but in this case, x is my function. So that's 5, my f of x. Okay, so I end up with 5 bracket 6 squared 5x minus 1. Okay, took one step. But if you want to give the chain rule a go, by all means keep practicing that just so that you get more familiar, to become more familiar with the chain rule when you think, okay, that's an alternative method, or if the question says use the chain rule, you can do it. Okay, part C. So over here is C at the top. Okay, so C, we're looking at y equals sine bracket ax plus b. Okay, so let's have a look at this one. I'm going to do this in a separate video because I think I'm running out of space here. So I'll do C next. Okay.